Good evening. Today we'll just be discussing some short Prolog code to answer one of the problems from our book. The problem that we'll be dealing with is right here. As you can see, I've been working on it already. But what we aim to do is show that there are varying sets of numbers where no numbers are the same. That can be applied to the letters TWO and FUR to create 2 plus 2 equals 4. So essentially when we do this, the T's can't be the same as the W's or the O's or the U's, so on and so forth. Everything has to be a different number corresponding to its variable letter. So we use Prolog to do this. The first thing that we have to do is just specify the name of our puzzle. So I named it 2's, and then put in how many different inputs it's expecting, and what those inputs should correspond to. So they should correspond to your different letters. In this case, we don't have to specify O twice because the O is going to be the same O here as it is in the O and 4 as it is in the O and 2. So the first thing that you have to do is just specify the variables. Once again, the variables are just the letters that we used for the problem. So the letters in 2 and 4. You then say that those variables can have any values between, I use 0 and 99. As you can see, because these are the answers that I used to prove it, you won't always, I didn't choose to go that high. I imagine there are some options. However, I didn't want to just use 9 because, for example, in this option, I made t equal to 12. You then say that all the variables have to be all different, and this is a nifty little Prolog built-in rule that specifies what I was trying to explain before, that none of the letters can have the same numerical value to start or at the finish. Then you go ahead and do the math. Essentially, O and O equals R, W and W equals U, T and T equals O again, and then the carry out of all of those equals F. One of the things to keep in mind is that, for example, if O were 7, 7 plus 7 equals 14. However, we just want R to be a single-digit value, so the carry, you do a remainder of 10, so that way R would equal 4, and the 1 would carry, which is done here, to be added to the W's. And the same thing occurs throughout. But that's pretty much all with that. So we'll go ahead and test it really quick. We can see that these two examples both work. 7, 3, 4, 1, 6, 8, as well as if t were 12, so 12, 3, 4. However, there are a couple different ways we can get this to fail. So, for example, if we don't put enough variables in to start, we will receive an error message. It's expecting 6 inputs, we only gave 3, so that'll cause an error. Another thing that'll cause an error is if you have crossover variables. So say you state that 2 are the same thing. So for example, 1, 3, 4, 1, 6, 8. The math wouldn't add up here either. However, it also will fail due to the fact that you have 2 different ones. An example where we don't have 2 of the same, however we do fail for mathematical issues, could be 0, wrote it down, give me 1 second, 0, 1, 4, 5, 6, 8, so we don't have any We don't have any crossover here. However, we're going to fail because these don't work out. 2 and 2, or T plus T should equal O. However, here we specified that T was 0 and O was 4. So that obviously wouldn't work because 0 plus 0 is 0. But anyways, that's just a short bit of Prolog code. If you want access to this, or just to view the rest of the problem, or the problem description in general, please refer to the rest of my blog. Thank you.